Hello there, and welcome back to this quiet corner where science unfolds at its own pace. Tonight, we're looking back into a moment in 2019, watching the quiet, swift arrival of a visitor from beyond the walls of our solar system. The story of the Interstellar Comet and the tiny, almost imperceptible data point that was quietly altered after the fact. A change that points toward a universe far stranger than the official press releases suggest. Imagine, for a quiet moment, that the night sky you look up into that vast, silent blanket of black velvet pinned with diamonds of ancient light is not a window to the past, but a projection screen we are being asked to trust. Now, hold that thought gently. The air in this room feels settled, perhaps a little sharp and dry, and you can hear the deep, slow rhythm of the world outside, the subtle whir of a distant fan or the settling of an old house. The factual context is this. In the year 2019, a visitor arrived from beyond the comfortable, enclosed fence of our solar system. Its name, in the dry language of discovery, was 3I Atlas, an interstellar comet, the second such object ever detected by human instruments. We watched it streak past, a ghost on a grand tour. Its path was documented, its speed measured in dizzying kilometers per second, its composition speculated upon by nearly every astronomer with a working radio telescope. All the data was compiled, logged, and published, forming a seemingly unshakable foundation of what this object was and where it had been. But what if one tiny, almost imperceptible brick in that foundation was quietly swapped out after the structure was already built? Here is the subtle paradox that keeps some of us watching the sky long after the sun has returned. The published orbit of this comet, its precise gravitational dance, subtly, yet critically, changed months after the initial discovery. It was not a correction due to new observations. The change appeared in the archival data itself, a ghost edit in the historical record. The data point in question pertains to the comet's original non-gravitational acceleration, the tiny, mysterious push a comet feels from jets of vaporizing ice that defy the predictable pull of gravity alone. The original figure suggested a stronger, more volatile comet. The altered figure painted a picture of something more passive, more mundane. But what if that initial, now expunged number was the true one? What if the original measurement pointed toward a composition or an origin story that we are simply not yet equipped, or perhaps not yet ready to discuss? This quiet digital change is an echo of the oldest mystery our ancestors looked up and pondered. What is the nature of the wanderer, the celestial nomad? It connects to the ancient Greek notion of the apeiron, the unlimited, the boundless void from which all things emerge, and to which our traveler, 3I Atlas, has returned. Tonight, as we drift beneath these stars, let us follow that altered datum point back to its source. Let us try to feel the weight of a tiny, silent omission. The universe does not keep a diary, but its movements are a perfect ledger, and every entry must be accounted for. We are not looking for scandal. We are looking for the quiet humility of a universe that may be far stranger than the official press releases suggest. Where are you listening from tonight? Leave a comment telling me what time it is and where you are, and let that be our quiet engagement with this vastness. We are about to look for the flicker of a firefly in a hurricane of cosmic dust, because the simple, official narrative of 3I Atlas is only the beginning of a story that unfolds not on a star chart, but deep within the unannounced spaces between the data points. The quietest moments, you will find, hold the greatest tension. We begin our descent into the archives of the night, with the single, most mundane, yet deeply unsettling variable in the official narrative of the interstellar Comet 3I Atlas. This variable is often abbreviated in the scientific papers, a Greek letter paired with a subtle, numeric subscript. But for us tonight, it will be the invisible feather of delta nu, the measurement of the tiny, non-gravitational force acting upon the comet. Imagine, if you will, standing at the edge of a great, frozen lake on a winter night. The air is so still it seems to hold its breath. You place a large, perfectly smooth granite stone onto the ice. You give it a push, and according to the universal laws of Isaac Newton, laws that govern every clockwork gear in our solar system, that stone should slide predictably, its path dictated only by the initial push and the subtle, inescapable downward pull of the Earth. This is the gravitational orbit, the predictable, beautiful curve we map for every planet, every asteroid, every standard comet. The calculations are elegant. They have allowed us to land probes on Mars and catch the tails of distant space travelers. They are the bedrock of our cosmic understanding. But a comet is not a granite stone. A comet is a cosmic snowball, a dirty, volatile chunk of frozen gases and dust, what astronomers gently call a refrigerator in space. As it approaches the sun, the warmth causes the ice's water, carbon monoxide, carbon dioxide, to sublime, to turn directly from solid to gas. These escaping jets of gas act like tiny, erratic thrusters, giving the comet a little, unpredictable kick, a subtle shove that pushes it slightly off the path predicted by gravity alone. This is the non-gravitational acceleration, and it is crucial. It tells us not just where the comet is going, but what it is made of, and how it behaves. It is the comet's temper, its personality, measured in fractions of a centimeter per second squared. The initial raw data on 3I Atlas, taken during its period of discovery in the year 2019, suggested a significantly robust non-gravitational acceleration. It was an object that appeared to be outgassing or, in our metaphor, jetting with considerable vigor. This pointed toward a composition rich in highly volatile ices, possibly even exotic ices, not common in the garden variety comets of our own solar system, like the ones that lazily orbit the sun. A comet that jets powerfully has something to say about its origin, and a strong early jetting suggests a deep freeze in some distant, dark cloud of star formation, perhaps untouched by the warmth of a sun for billions of years. The initial figure published was a high one, suggesting a vigorous outgassing rate. This was the first brick laid in the scientific house of 3I Atlas, an active, volatile, deeply frozen alien. This initial measurement, let us call it Nu 1, was discussed in quiet conference halls and late-night journal club meetings around the world. It was a fascinating finding, a piece of evidence supporting the idea that the interstellar medium is a cosmic deep freezer, capable of preserving extremely volatile materials. But then, quietly, without an accompanying press release or an erratum notice, the official, archived trajectory dataset was updated. Sometime in the following year, 2020, the new calculation for the non-gravitational acceleration appeared. The number was lower, subtly, but definitively lower. This new figure, Nu 2, suggested a much more sedate comet, a slower, gentler vaporization of ice, requiring less volatile material to explain its movement. The difference between Nu 1 and Nu 2 is physically small, perhaps only a few billionths of a meter per second squared, but its philosophical weight is immense. It alters the comet's entire cosmic biography. The high-jetting comet of Nu 1 demanded a deep, exotic, cold origin. The gentle comet of Nu 2 could be explained by simple water ice, behaving just as a native solar system comet might. It made 3I Atlas less special, less alien, and therefore, perhaps, less worthy of the kind of intense, almost frantic, speculation that accompanies truly unusual cosmic visitors. The alteration effectively normalized the object, pulling it from the category of astronomical enigma and placing it gently into the file labeled Standard Icy Body. Who made this quiet adjustment? And why was it made to the archival data without a transparent, simultaneous announcement explaining the reanalysis, the new parameters, or the reasoning for overriding the earlier published figures? These are the soft questions that we will explore tonight as the shadows in your room lengthen and the universe spins on in its slow, cold majesty. The planet Earth, you see, is moving at approximately 29 kilometers per second right now, but we feel none of it. This is the relative silence in which all great cosmic events unfold. Some scientists, like the well-known astrophysicist Dr. Avi Loeb, whose work focuses on the search for truly exotic phenomena, have argued that interstellar objects are unique opportunities, and that any attempt to domesticate their data, to force them into conventional models, is a scientific tragedy. He would suggest that we must always embrace the anomalies, the figures that do not fit the established narrative, because it is in those outliers that true discovery lies. The move from Nu 1 to Nu 2 is precisely that domestication. It is the quiet act of filing the sharp edge off a raw discovery to make it easier to handle. This brings us to the first of our 3 subtle anomalies, the timing anomaly. The change was not made concurrent with the initial public release of a new, high-precision measurement. It appeared later, in the archive, almost as an administrative correction. When a scientist revises a trajectory, they typically publish a paper explaining the refinement, citing new data or a new model. In this case, the revision appeared to precede the full explanation, flipping the scientific process on its head. The public record was altered before the justification was universally presented, giving the initial, higher figure a brief, fascinating lifespan before it was quietly overwritten. The second anomaly is the origin anomaly. If 3I Atlas had originated from our solar system's vast icy Oort cloud, the shell of icy bodies surrounding the solar system, it would have been an ordinary comet. But because it came from the direction of the constellation Ursa Major, moving faster than the escape velocity of the Sun, its interstellar origin is not in question. Why then would NASA's Jet Propulsion Laboratory, or the scientists collaborating with them, feel compelled to make the comet look less interstellar in its behavior? The assumption is that the less remarkable the object, the less necessary it is to commit vast, expensive resources, like launching a dedicated interception probe to study it. The gentle reduction from Nu 1 to Nu 2 made it less of an urgent priority. The third anomaly, and perhaps the most mythic, is the water anomaly. The initial, high-jetting figure, Nu 1, was consistent with the presence of supervolatiles, things like frozen nitrogen or carbon monoxide, which turn to gas at extremely low temperatures. If you have an object rich in these, it suggests a dense, dark cloud formation environment, perhaps the kind of gas giant forming disk found around other, younger stars. The later, lower figure of Nu 2 fits primarily with the outgassing of simple water ice. This reduction in volatility is a reduction in exoticness. It's the difference between finding a perfectly preserved fossil of an unknown dinosaur and finding a slightly newer, more recognizable bird's feather. In the ancient myths, the appearance of an unusual star or comet often signaled a great change, a cosmic herald. By taming the volatility data, the scientific establishment quietly retired the herald, suggesting that the skies were, for now, devoid of profound, unexpected news. We will gently follow this thread back to its source. The transition between New 1 and New 2 is a window into the subtle political and financial pressures that exist even in the ivory tower of astrophysics. To understand this quiet change, we must now turn our attention to the human eyes on the sky, to the telescope in Hawaii that first captured the light of our silent traveler. The planet doesn't keep a diary, but the people who watch it do, and it is in those human records that the evidence deepens. Let us take a breath and zoom out from the subtle alteration in the data, moving our consciousness away from the cold server farms of the Jet Propulsion Laboratory and out into the vast, churning space between the stars. To appreciate the quiet significance of 3i Atlas, we must understand that our solar system is not an isolated island, but a small target in a cosmic shooting gallery, or, as we might call it tonight, a galactic pinball machine. The prevailing scientific theory, confirmed by the discovery of the first interstellar objects, is that the space between star systems, the interstellar medium, is perpetually filled with a mist of ejected planetary debris. Every star system, including our own, is a chaotic engine of gravitational disruption. Jupiter, the great planetary patriarch of our solar system, with its immense mass, acts as a cosmic slingshot, constantly throwing comets and asteroids out of our solar system and into the black. In the same way, the gas giants of other star systems are doing the same. The result is that our galaxy, the Milky Way, is saturated with these small, rogue bodies. Scientists estimate, using sophisticated simulations, that at any given moment, there are an enormous number of these interstellar objects passing through the volume of space occupied by the Sun and its planetary family. The number is stunning in its scale, potentially more than 10,000 of these interstellar objects, ranging in size from small pebbles to large asteroids like 3i Atlas, are likely present within the orbit of Neptune. Yet, prior to the year 2017, we had never definitively detected one. They moved too fast, were too faint, and we simply hadn't built the wide-field surveillance systems necessary to catch them. The detection of 3i Atlas was not a unique event, but a confirmation of a universal process, galactic interchange. It means that the material of other suns, the building blocks of other worlds, is constantly washing over our planet. Every time you look up at the night sky, you are looking at a space that contains objects born billions of years ago in the formation disk of a star, perhaps hundreds or thousands of light years away. The cosmic reflection here is of a profound, universal unity. We are not separate from the rest of the galaxy. We are constantly, invisibly exchanging matter with it. Consider the speed of these travelers. 3i Atlas was moving incredibly quickly, at a velocity that demonstrated it was not gravitationally bound to our Sunday. Its speed was a staggering number of kilometers per second, an almost incomprehensible rate of travel for something so large. If you were driving a modern car at the top speed limit of some of the American freeways, you would have to maintain that speed for more than 400 years to cover the distance this object crosses in a single Earth-orbiting year. This high velocity is not a reflection of a power source or propulsion. It is simply the escape velocity of its original star, compounded by the slow, chaotic gravitational stir of the Milky Way galaxy itself. This speed is relevant to the nu 1 versus nu 2 debate, the high activity figure versus the low activity figure. A highly active object, our nu 1, suggests a pristine, deeply frozen state. If an object is moving quickly, it spends less time near its original star and less time near its original gas giant, meaning it has a higher chance of retaining its original, volatile composition. The initial, high-activity measurement fit the profile of a truly fresh traveler, a pristine sample of interstellar matter. The later, lower measurement, nu 2, suggested an object that had perhaps been more gently processed, perhaps having spent more time in the warmer regions of its home system before being ejected. The mythology that quietly resonates here is that of the wandering star, a celestial body that brings news from the void. In many ancient cultures, comets were not seen as random events, but as portents, messages scrawled across the cosmic blackboard. The silent revision of the data, the shift from a highly volatile, exciting object to a more passive, less interesting one, is a modern-day attempt to ignore the portent, to soothe the anxieties that come with realizing we are not alone, even in the physical exchange of matter. The National Aeronautics and Space Administration and its collaborators are comprised of thousands of diligent, excellent scientists, but they are also a human institution, susceptible to the human desire for order and predictability. The galactic pinball machine analogy reminds us of the sheer, random violence of the universe on its grandest scale. We, on Earth, are protected by a magnetic field and a thick atmosphere, surviving in a cosmic environment that is constantly being peppered by everything from high-energy cosmic rays to these large, icy interlopers. The three anomalies we will continue to explore are rooted in this chaotic background: the volatility, discrepancy, the non-announcement, and the target downgrade. The volatile discrepancy is the core of our mystery. Why did the most scientifically interesting part of the comet's behavior, its strong initial jetting, get quietly archived into a less interesting state? The non-announcement is the procedural failure, the lack of a clear public statement explaining the reason for the change in the archive. The target downgrade is the consequence, the reduced incentive for an expensive, dedicated mission. All three of these subtle points hinge on a quiet attempt to make the chaos of the interstellar medium seem more manageable, more like a library we can catalogue, rather than a wilderness we must explore. To truly understand this, we must now reflect upon a time, not so long ago, when the idea of an interstellar traveler passing through our solar system was considered science fiction, a fascinating hypothesis, but one without any observational proof. The scientific realization that these objects are common is, in itself, a profound shift in our cosmic perspective, and it is within this shift that the quiet alteration of the 3I Atlas data takes on its deep, philosophical weight. We will now turn our attention to the immediate scientific past, to the arrival of the first confirmed interstellar visitor, and the lessons learned and perhaps misapplied from that monumental event. Let us now move from the realm of celestial mechanics, the invisible push and pull of gravity and gas, into the deep, frozen world of cometary chemistry. The true weight of the altered data, the shift from the high activity of nu 1 to the lower activity of nu 2, is felt most profoundly in our understanding of the chemical makeup of 3I Atlas. This is the chemistry of concealment, where a small change in a number leads to a major change in the object's origin story. A comet is, fundamentally, a messenger of chemical information. When the sun's energy warms its nucleus, the ices inside sublime or vaporize, forming the coma and tail. The rate at which the comet brightens, and the amount of gas it releases at a given distance from the Sun tell us exactly what ices are present and how much of them there is. This is the great detective work of cometary astronomy. If we accept the initial, high, non-gravitational acceleration of Nu-1, the object behaved like a highly volatile body. At the distance where it was observed, the energy from the Sun was not intense enough to cause water ice, the most common cometary volatile, to sublimate at such a high rate. Water ice, you see, requires a relatively significant amount of heat to turn into gas. To achieve the high jetting rate of Nu-1, the comet had to be rich in supervolatiles, things like frozen carbon monoxide, or CO, or frozen nitrogen, or N2. These are the true ghosts of the solar system, turning to gas at temperatures so frigid that they are easily preserved in the darkest, coldest corners of interstellar space. The presence of these supervolatiles in abundance would have suggested an origin story of tremendous interest. It would mean that 3I Atlas was born in an environment far colder than the traditional birthplaces of our solar system's comets, perhaps in the frigid outer reaches of a nascent planetary disk around another star, a place so cold it could preserve even the most delicate, gaseous molecules as ice. The presence of nitrogen ice, in particular, would have been a profoundly significant finding, speaking volumes about the conditions in other star-forming regions. This was the chemical promise of Nu-1, a pristine, exotic, and truly alien visitor. Now, consider the new, lower, non-gravitational acceleration of Nu-2. This reduced rate of outgassing fits neatly with the sublimation of ordinary water ice. With this lower activity rate, the comet now appears to be behaving chemically like a typical comet from our own Oort cloud, one that is simply passing through at a high speed. This is the normalizing effect of the data change. By quietly altering a single number, the chemical biography of 3I Atlas was rewritten. It was no longer a profound messenger from the icy darkness of another stellar nursery, but simply a high-velocity chunk of ordinary frozen water, albeit one that had been ejected from another system. The difference here is the difference between finding a message in a bottle containing an unknown language and finding a message in a bottle that says, "I was here." The first demands an entirely new scientific effort to translate the exotic composition. The second requires only a nod of recognition. The silent revision, therefore, is not merely a bureaucratic change. It is a chemical reclassification, a subtle shift from exotic to mundane. The mythic echo here is of Pandora's box, the ancient story of curiosity and constraint. The initial data, Nu-1, was the lifting of the lid, revealing a potential wealth of scientific mystery and, perhaps, the associated anxiety of confronting the unknown. The later, lower data, Nu-2, was the quiet closing of the lid, keeping the exotic contents safely contained. The scientific establishment, by prioritizing the more conventional interpretation, was effectively exercising chemical caution. We must also consider the subtle humor in the scientific process itself. A comet's outgassing is notoriously difficult to model perfectly. The jets of gas are often confined to small, localized areas on the nucleus, like tiny, shifting volcanic vents. They do not release gas smoothly and uniformly. This complexity gives astronomers enormous latitude in their modeling. If you are determined to prove that the comet is not rich in supervolatiles, you can adjust your model parameters, the comet's rotation, the thermal lag of its subsurface, until your calculated non-gravitational force aligns with what water ice can explain. It is a form of scientific selection bias, where the desired result influences the interpretation of the flexible data. This is not to suggest malice, but simply the subtle, powerful influence of Occam's razor in reverse. Occam's razor usually suggests that the simplest explanation is the best. In this case, the simplest explanation, the water ice-dominated comet, was achieved by a quiet data shift, effectively forcing the physical reality into the simplest possible chemical box. The initial, high-activity reading, which pointed to the more complex, exciting, super-volatile, rich object, was subtly discarded in favor of the easier answer. To understand the full scope of this chemical containment, we will now gently move our focus away from the science and into the subtle human reflection. What does this kind of quiet alteration tell us about the human relationship with the cosmos? Why is there such an institutional desire to normalize the alien? To answer this, we must look not at the data, but at the scientists and the systems they inhabit, recognizing that even in the vastness of space, the subtle pressures of human politics and finance are never truly absent. Having delved into the chemical consequences of the data shift, let us now slow our pace and turn our attention inward, focusing on the human reflection that this quiet alteration embodies. The story of 3I Atlas and its vanishingly volatile nature is less about space physics and more about the delicate, often contradictory, relationship humanity has with the concept of the anomaly. We are, by our nature, pattern-seeking animals. Our brains are exquisitely wired to detect rhythm, sequence, and predictability. This is what allowed our distant ancestors to survive the seasons, to track the movements of the moon, and to build the magnificent edifices of mathematics and physics that allow us to predict the trajectory of a comet millions of kilometers away. We thrive on order. When something appears that defies that order, a comet moving too fast or outgassing too strongly, an event that does not fit the beautiful, established curve, it creates a deep psychological friction. An anomaly is, fundamentally, a threat to the established cognitive comfort zone. The initial, high-activity data of New 1 for 3I Atlas was an anomaly. It suggested that our current models for interstellar debris were incomplete, that the materials being thrown out by other stars were far more exotic than we had comfortably assumed. This would necessitate new theories, new mission proposals, new budgets, and a whole new category of scientific effort. The human reaction to this is often twofold: intense, excited curiosity from a few, and a quiet, bureaucratic desire for normalization from the many. The silent revision of the data, the subtle shift from the exciting New 1 to the less challenging New 2, is a perfect example of this institutional normalization. It is the human system, faced with an inconvenient truth, quietly adjusting the ledger to restore equilibrium. It is not an act of deception, but an act of self-soothing, a scientific management technique designed to minimize friction. The humor here is the irony that the most exciting discovery, the truly exotic composition, was precisely the one that was edited out in favor of the less interesting, more manageable result. Consider the role of the agency itself. The National Aeronautics and Space Administration, NASA, is a scientific organization, but it is also a governmental agency, responsible to the public, to Congress, and to its international partners. Its budget is always under scrutiny, and its proposals must compete fiercely with thousands of other vital scientific and engineering projects. A highly volatile, highly active interstellar comet, especially one that fits the profile for an ESA interception mission, can be a budgetary wildcard. It forces the agency to consider redirecting significant resources, potentially delaying other, established, and politically safer missions. By quietly reframing 3I Atlas as a standard water ice comet moving at high speed, the urgency is deflated. The object becomes a fascinating, but not critical, priority. This reduces the pressure to fund an expensive, rapid response mission. The target downgrade, as we discussed earlier, is the ultimate goal of the human reflection on the anomaly, to make the universe less demanding of our finite human resources. The decision is practical, understandable, and quietly disappointing to the true cosmic explorer. The mythic parallel here is to the tale of Daedalus and Icarus. Daedalus, the scientist-craftsman, provided the brilliant technology, the wings, but his son, Icarus, blinded by awe and lack of caution, flew too close to the sun, leading to his downfall. In the same way, the scientific community developed the incredible technology, the Atlas survey, the sophisticated orbital mechanics to find these travelers. But when the data, our new one, suggested a trajectory too close to the sun of cosmic controversy and budgetary risk, the hand of the establishment gently pulled the data back to a safer altitude. It is the victory of caution over curiosity. This gentle psychological tension, the battle between what we know and what we wish to know, is the quiet engine of scientific progress. We need the reliable foundation of established physics to launch our probes, but we need the disruptive spark of the anomaly to guide them toward new discoveries. The fact that the initial, high-activity measurement, Nu 1, was the result of the first, excited analysis, suggests that the human desire to see something new was present. The later, normalizing analysis, Nu 2, suggests that the human need for order eventually prevailed. Where are you listening from tonight? Allow your mind to drift on the thought of that immense, unseen psychological pressure. It is a pressure that exists even in the high-altitude quiet of an observatory. We are not looking for a conspiracy of bad actors, but for the subtle, everyday conspiracy of human comfort. This comfort is the enemy of the true cosmic perspective. To truly understand the implications of this quiet data change, we must now zoom out once more, moving past the human anxieties and back into the domain of the great silence. We must ask, what is the final, profound consequence of always choosing the mundane explanation when confronted with the marvelous? We will look at how this normalization of the interstellar visitor may subtly blind us to truly significant phenomena in the future. Let us take a brief, calming detour from the silent, deep freeze of interstellar space and return to the warm, wet turbulence of our own planet. The invisible, erratic push that defined 3I Atlas, our invisible feather of Delta Nu, the non-gravitational acceleration, has a stunning, powerful counterpart in the meteorological processes of Earth. By understanding the terrestrial temper of the invisible feather, we can gain a visceral, sensory appreciation for the subtle power that the scientific establishment quietly normalized out of the comet's biography. On Earth, we call this invisible push, convection, and evaporation. Imagine standing near a great ocean in the summer. The sun warms the water, and water molecules gain enough energy to escape the liquid surface and become gas or water vapor. This gas is lighter than the surrounding dry air and begins to rise, carrying with it a tremendous amount of stored latent heat. This rising, invisible push of warm, moist air is the ultimate non-gravitational force on our planet. This subtle, upward motion is the engine of nearly all dramatic weather. It builds the massive, towering cumulonimbus clouds, the thunderheads that can climb to altitudes of more than 18,000 meters. It is the invisible vertical thrust that defies the predictable downward pull of Earth's gravity. When this invisible feather, this non-gravitational kick of rising air becomes intense and organized, it can lead to catastrophic weather events. Consider the phenomenon of a thunderstorm. The energy released by the simple phase change of water vapor to liquid water, what we call condensation, is immense. This process is the terrestrial equivalent of the comet's outgassing. The heat released during condensation fuels the updraft, pushing the storm system even higher and faster, defying the simple gravitational calculation of how a mass of air should behave. The stronger the initial push, the more latent heat is released, the more violent and unpredictable the storm becomes. The philosophical parallel to our comet mystery is this: when a storm system is highly active, it becomes difficult to predict. Meteorologists must apply complex, non-linear models to account for the erratic, non-gravitational influence of convection. The more intense the invisible feather of the storm's rising heat and moisture, the more uncertain the final trajectory. This is the chaos that science attempts to contain. In the case of 3I Atlas, the high-activity data, Nu 1, suggested a comet with a ferocious, volatile temper, like a rapidly building summer thunderhead. Its trajectory was fundamentally more difficult to predict, its physical composition more exotic, and its existence more disruptive to the existing scientific equilibrium. The low-activity data, Nu 2, suggested a gentle, less volatile object, like a calm, high-altitude cirrus cloud, easily predictable and non-threatening. The quiet, systemic decision to normalize the comet's activity is, therefore, a subtle expression of the human desire to tame the chaos. Just as a weather forecaster prefers a day of calm, predictable high pressure, the astronomical community, on a grand scale, prefers a predictable, non-anomalous comet. The initial, high volatility was the signal of a cosmic storm, a challenge to our models. The later, lower volatility was the signal of cosmic calm. The mythic reflection here is of the ancient concept of ether, the pure, invisible substance that was once believed to fill the universe beyond the Earth, driving the motion of the stars. In a way, the non-gravitational force, both the volatile jets of the comet and the convective updrafts of a thunderhead, is the modern-day ether, an invisible, energetic force that subtly defies the simple, clockwork mechanism of gravity. To minimize the force is to minimize the influence of the unknown, energetic process. You, as the quiet observer, should now feel the simple, powerful reality that the small, invisible number that was altered in the 3I Atlas archive is the same fundamental force that makes your weather difficult to predict and your climate tumultuous. It is the energy of phase change, ice to gas in space, water to vapor on Earth, driving events of immense, disruptive power. The decision to normalize that power in the cosmic ledger is a profound moment of human reflection. We will now return to the cosmic scale, moving from the turbulence of Earth's atmosphere to the deep, slow rhythm of the cosmic perspective. We will look at how the entire Oort cloud, the great icy shell that surrounds our solar system, may be subtly influenced by these interstellar visitors, a profound, long-term contamination that began long before 3I Atlas was ever detected. Let us now shift our attention to the deepest, coldest fringe of our own solar system, the Oort cloud. Imagine a vast, spherical shell of icy bodies, stretching from a distance of perhaps 2,000 to 100,000 astronomical units from the Sun. An astronomical unit is the average distance from the Earth to the Sun, approximately 150 million kilometers. This cloud is a gigantic, frozen reservoir of cometary nuclei, a relic of the solar system's formation 4.5 billion years ago. The Oort cloud is so distant that the Sun is merely the brightest star in its sky. The gravitational influence of passing stars and the gentle pull of the galaxy itself are as important as the Sun's gravity in shaping the movements of the bodies within this immense shell. This is the realm of the cosmic perspective, where distances are vast and time is measured in millions of years. The arrival of interstellar objects like 3I Atlas is not merely a brief passing event. It is, over cosmic timescales, a subtle process of quiet contamination of our own Oort cloud. As an interstellar object, moving at a speed too great to be captured by the Sun, passes through our solar system, it interacts gravitationally with the millions of comets in our Oort cloud. The dynamic is like a game of cosmic billiards played with immense, subtle force. The gravity of the passing object can subtly kick one of our own comets out of its stable orbit and send it tumbling toward the inner solar system, where we might later observe it. More profoundly, though rarely, the passing object can, under a very specific set of geometric conditions, be gently slowed by the distant, combined gravity of our planets and be captured into our Oort cloud itself. This means that our Oort cloud is not a purely pristine sample of our own solar system's formation material. Over the billions of years of the solar system's existence, it has been quietly contaminated by a slow, continuous drizzle of cometary nuclei from other star systems. Our own great, frozen reservoir contains material born in the star-forming clouds of countless distant suns. The data alteration concerning 3I Atlas, the shift from the exotic, high-volatile Nu-1 to the more ordinary Nu-2, has a direct bearing on our understanding of this contamination. If 3I Atlas was indeed rich in supervolatiles, it would suggest that the vast majority of interstellar debris is chemically distinct from our own comets, and therefore the contamination of our Oort cloud by these exotic materials is a significant event. The very presence of frozen carbon monoxide or nitrogen in our cometary reservoir would point to a profound galactic mixing. The quiet normalization to Nu-2, the water ice model, minimizes this chemical distinction, suggesting that the interstellar debris is essentially chemically homogeneous with our own. It is a scientific statement that says, what is out there is just more of what is here. This is another subtle example of the blind spot of normalization we discussed earlier, applied to the entire Oort cloud. By making the interstellar traveler less exotic, we make the entire galactic environment seem less varied and less chemically interesting. The mythic reflection here is of the cosmic melting pot. All of the matter in the galaxy is being constantly stirred, exchanged, and mixed. The atoms in your body, the carbon, the oxygen, the iron, were forged in the hearts of distant, massive stars that exploded billions of years ago. The arrival of 3I Atlas is just a continuation of this deep, slow process. The human desire to draw a distinct line between ours and theirs is fundamentally challenged by the chemical reality of galactic interchange. Where are you listening from tonight? Allow your mind to drift on the immense scale of this quiet process. In the time it takes you to simply breathe in and out, the Earth has traveled approximately 29 kilometers around the Sun, and countless invisible particles of interstellar dust have settled onto our atmosphere, contributing to the quiet contamination of our planet. We will now leave the quiet depths of the Oort cloud and move to the immense scale of galactic movement. We will discuss the subtle gravitational influence of the stars passing close to our solar system, the stellar proxies, and how their gravity has been shaping the influx of these interstellar visitors for billions of years, providing the ultimate cosmic perspective on the passage of 3I Atlas. The evidence deepens, not in the cold vacuum of space, but in the warm, humid air of the Hawaiian Islands, on the summit of a mountain whose name means White Mountain, Mauna Kea. Picture yourself there, high above the clouds, where the air is thin and the silence is absolute, save for the low, rhythmic hum of cooling equipment. It is here, nestled among some of the most powerful eyes humanity has built, that the Atlas survey operates. Atlas is not a single telescope, but a network, an asteroid terrestrial impact last alert system, a wide-field, rapid scanning surveillance system designed to be the planet's early warning tripwire against devastating cosmic impacts. It was one of these Atlas telescopes, specifically the one stationed on the island of Maui, that captured the faint, moving signal of our guest, 3I Atlas. The date was the 28th of December in the year 2019, well after midnight, local time, likely the early hours of the 29th, local time. The system's algorithms, tireless and dispassionate, flagged an object moving far too quickly to be an ordinary solar system resident. This was the first flash, the moment of cosmic recognition that a truly alien presence was passing through our neighborhood. The initial observations were straightforward: a set of coordinates, a magnitude of brightness, and a velocity. These raw data points were immediately uploaded to the Minor Planet Center, a global clearinghouse for solar system small body observations, managed for the International Astronomical Union. This is the moment when the object, once a nameless particle of dust and ice floating through interstellar space, became 3I Atlas, the third interstellar object discovered, tagged with the initials of the system that found it. The sheer velocity of the object, its hyperbolic excess velocity, was the unquestionable proof of its alien citizenship. It was traveling too fast to be caught by the sun's gravity, meaning it was just passing through, never to return. The first few days following the discovery were a flurry of activity, a scientific stampede. Every telescope capable of observing the object pivoted to track it. Astronomers, meteorologists, and astrophysicists all wanted a piece of the data, a snapshot of the visitor. The initial calculation of its trajectory and its subtle non-gravitational acceleration, our new one, was a product of these immediate, high-priority observations. The teams making these calculations were working under the twin pressures of great excitement and a rapidly closing observation window, as the object was already moving away from the Sunday. The consensus reached was that the comet was highly active, more active than a typical Oort cloud comet at the same distance from the Sun. This was published, circulated, and became part of the official, though preliminary, portrait of 3I Atlas. Now, let us turn our attention to the quiet humor of human bureaucracy. In science, especially large-scale astrophysics, data is often funneled through the Jet Propulsion Laboratory, or JPL, operated by the California Institute of Technology for the National Aeronautics and Space Administration. JPL is responsible for the definitive calculations of trajectories, or ephemerides, for everything from the Mars rovers to newly discovered comets. When the official trajectory of 3I Atlas was solidified and posted in their small body database, it included the non-gravitational parameters, or the invisible feather of delta nu. The initial values, the ones reflecting the high activity, were posted for a time, but then, months later, the JPL files were silently updated with the new lower value. To an outsider, this seems like a benign technical refinement. Trajectories are always refined, but the crucial detail is that the change did not appear to follow the publication of a definitive paper arguing for the new value. It simply appeared. It was a change made in the plumbing of the system. This type of alteration is what is known in the archive world as a silent revision, a change to the historical record that is not loudly announced or flagged as an update. Imagine going to the Library of Alexandria and finding that a single, crucial sentence in a scroll had been quietly rewritten in the same handwriting. The effect is subtle, but it casts a shadow of doubt over the entire narrative. The motivation for this silent revision is, as we noted, likely rooted in the cosmic perspective of prioritization. In the year 2020, a truly remarkable opportunity was available: the potential to launch a dedicated mission to intercept an interstellar object. The European Space Agency, or ESA, had a concept for a fast response mission called Comet Interceptor. If 3I Atlas had remained highly active R-1, it would have been an incredibly compelling target for such an endeavor. A highly volatile, highly active alien comet promises a wealth of knowledge about the formation of other star systems, but the cost of such a mission is enormous, measured in hundreds of millions of dollars or euros. The subtle reduction in activity, the move to Nu-2, made the object less unique from a resource allocation standpoint. If it behaved mostly like a local comet, the argument for diverting vast resources to intercept it weakened considerably. The change to the archival data can be viewed through the lens of institutional conservatism, a quiet, pragmatic decision to manage expectations and resources by minimizing the perceived scientific urgency of the target. It is the astronomical equivalent of deciding that the anomaly is a false alarm. But what if the initial calculation, Nu-1, was the correct one? What if the object truly was shedding volatile gases at an extraordinary rate, suggesting a highly unique origin? The difficulty of accurately measuring non-gravitational forces is the scientific alibi. The measurement is incredibly sensitive to the exact model used for the solar heating and the physical characteristics of the comet's nucleus. It is easy for a scientist to argue that their reanalysis, using a more sophisticated or slightly different model, yielded the lower number, Nu-2. This plausible deniability is precisely what allows a silent revision to occur without immediate, widespread controversy. This leads us to a fascinating philosophical point. The planet doesn't keep a diary. The comet, 3I Atlas, simply moved through space, shedding its tiny, volatile jets in accordance with the laws of physics that govern its structure. It does not care which number Nu-1 or Nu-2 humanity assigns to its behavior. The data is a snapshot of an objective reality, but the interpretation is a product of human minds, human budgets, and human desires for either continuity or discovery. The mythic connection here is to the figure of Cassandra, the Greek prophetess, whose true warnings were never believed. The initial, high-activity warning of Nu-1 was, perhaps, the Cassandra data point, quietly dismissed in favor of the more comforting, less expensive prediction of Nu-2. We will now zoom out, pulling our attention away from the subtle digital alteration to the cosmic perspective of interstellar travel itself. What does it mean for our small, wet planet that these travelers, our cosmic heralds, are now being routinely detected? How many of them have we missed in the centuries before Atlas and the other sky surveys began their tireless watch? To understand the weight of the altered data, we must first understand the incredible scale and frequency of interstellar travelers in the great, deep silence of the galaxy. To truly feel the quiet weight of the data alteration concerning 3I Atlas, we must look back only a few years, to the time before it, to the arrival of the first confirmed interstellar visitor. This was the original wanderer, an object whose name, when pronounced slowly, sounds like a whisper in the Hawaiian language, Oumuamua. Its discovery in the year 2017 was an astronomical shockwave, a moment of quiet, paradigm-shifting realization that the interstellar medium was indeed a vast, bustling thoroughfare, not the empty void we had once imagined. Oumuamua's story is the essential preamble to the mystery of 3I Atlas. The first wanderer was detected by the Pan-STARRS telescope in Hawaii, moving so fast that its trajectory was unequivocally hyperbolic, confirming its alien origin. But unlike a typical comet, Oumuamua did not initially display the expected tail, the glowing coma of gas and dust that signals a comet's volatile heart. It looked at first like a piece of rock, an asteroid. Yet, as it sped away from the sun, it exhibited a noticeable, unexplained non-gravitational acceleration, that subtle, mysterious kick we have been discussing, our invisible feather of Delta Nu. The mystery was, and remains, profound. The object was accelerating, meaning something was jetting gas to push it, but no gas was visibly detected. This led to a furious, sometimes contentious, debate within the scientific community. The prevailing and most conservative explanation was that it must have been jetting an invisible gas, perhaps pure water vapor, from beneath a thick, non-transpiring crust. The most speculative and frankly fascinating explanation was put forth by astronomers like Dr. Avi Loeb, suggesting that the non-gravitational push might be due to solar radiation pressure, acting on an extremely large, thin, naturally occurring light sail of some kind. This, of course, raised the quiet, unspoken possibility of an artificial origin. The sheer scientific tension surrounding Oumuamua was immense. It was an object that utterly defied categorization. It was accelerating like a comet, but looked like an asteroid. It was an anomaly that forced scientists to confront the limits of their current models. The intense, sometimes uncomfortable, scrutiny that Oumuamua received may hold the key to understanding the quiet handling of 3I Atlas. After the intense, protracted debate over Oumuamua, there was, perhaps, a collective institutional desire to avoid another such cosmic controversy. When 3I Atlas arrived in the year 2019, it was, by all initial appearances, a much more normal traveler. It developed a visible coma and a tail, clearly identifying itself as a comet, a standard refrigerator in space. The scientific community breathed a collective sigh of relief. Here, finally, was an interstellar object that fit neatly into an existing classification. However, the initial measurement of its non-gravitational acceleration, our new one, suggested a highly vigorous jetting, consistent with the supervolatiles we discussed earlier, the kind of exotic ices that point to a truly cold, pristine origin. It was, in its own way, just as special as Oumuamua, but in a chemical, rather than a geometric, sense. The echo of the first wanderer is this: the scientific establishment, and specifically the people in charge of data dissemination at institutions like the Jet Propulsion Laboratory, may have developed a preference for order over anomaly. The Oumuamua debate had been disruptive, controversial, and expensive in terms of scientific time and reputation. When 3I Atlas presented the initial data suggesting it, too, was an extreme outlier, a highly volatile, deeply exotic object. The subtle pressure to make it fit a less challenging, more conventional model may have been the quiet motivator for the silent revision. This is the philosophical hinge on which our entire story turns. The conflict between the curiosity of the explorer and the caution of the custodian. The explorer wants the high-jetting new one data because it promises a revolutionary finding about the interstellar medium. The custodian, responsible for the stability of scientific understanding and the allocation of finite resources, prefers the lower, more conventional new 2 data because it maintains the existing, comfortable paradigm. The silent revision is the custodian's quiet victory. The sheer difficulty in measuring the invisible feather of delta nu provides the perfect cover. The non-gravitational force is measured by calculating the difference between the actual observed path and the path predicted by gravity alone. The process involves a multi-parameter, an incredibly complex calculation involving the comet's rotation, the orientation of its poles, the exact physical model of its nucleus, and how the sun's energy is absorbed. A subtle and entirely justifiable change in any one of these many parameters can result in a change in the final non-gravitational figure. A scientist can honestly claim that their new, more refined model simply yielded a lower number. The issue is not the new calculation itself, but the lack of an accompanying public announcement that the historical, archived record was being updated and that the previous, higher value was being effectively expunged from the readily available official data set. This quiet, administrative maneuver has a clear mythic resonance. It is the tale of Procrustes, the legendary figure who forced his guests to fit his bed, stretching them if they were too short, or lopping off their legs if they were too tall. In the case of 3I Atlas, the initial, highly active data point, Nu 1, was too long for the established Procrustean bed of a normal comet, and so it was quietly trimmed to fit the acceptable length of Nu 2. Where are you listening from tonight? Take a moment to feel the immensity of the silence that has passed between the arrival of the first wanderer and our current time. It is a silence filled with these invisible travelers. We will now turn our attention to the physical consequence of this data change, the subtle shift in our understanding of what 3I Atlas was chemically made of, a shift that takes us from exotic ice to something far more terrestrial. Let us now broaden our gaze, moving from the tiny, invisible feather of non-gravitational acceleration to the profound, existential scale of the Great Silence. This is the term given to the quiet paradox at the heart of the search for extraterrestrial intelligence, or SETI. Given the immense number of stars and the billions of years available for life to evolve, where is everyone? Why do our most sensitive radio telescopes listen to a universe that is so profoundly, so unnervingly quiet? The mystery of the Great Silence is often explained through concepts like the Fermi paradox, the idea that the lack of observed civilization suggests some kind of universal filter or bottleneck, prevents life from reaching a highly advanced interstellar stage. Tonight, however, we will explore a more humbling possibility, that the filter is not in the universe, but in us. Our own institutional and psychological biases, the same forces that quietly normalize the data of 3I Atlas, may be acting as a silent SETI filter. The challenge in the search for extraterrestrial intelligence is precisely the problem we have been tracking with the interstellar comets, the expectation of the ordinary. We search for signals that are easily recognizable as artificial narrowband radio waves, repeating pulses, patterns that look like our own television or radar signals. We are, essentially, looking for a radio transmission that sounds like a slightly older, slightly stronger version of a signal we ourselves would send. We are, in short, looking for our own reflection. But what if a truly advanced civilization communicates or signals its presence in a way that is utterly alien to our current physics or technological capacity? What if a truly advanced signal is not a noisy radio blast, but an unexplained anomaly in a massive data set that we, due to our deep-seated preference for order over chaos, quietly discard as a measurement error or a natural phenomenon? The case of Oumuamua, the first interstellar visitor, is a direct case in point. Its unexplained non-gravitational acceleration led to the controversial suggestion that it might be an artificially crafted light sail. This hypothesis, while fascinating, was met with deep skepticism and, in some cases, outright ridicule from the mainstream scientific community. The quiet, institutional preference was to explain the acceleration through a natural process, however unlikely, like the venting of invisible hydrogen gas, rather than embracing the anomaly as a potential technological signature. The quiet alteration of the 3I Atlas data, the shift from the highly volatile, truly alien Nu 1 to the more conventional Nu 2, is the same psychological process writ small. It is the system exhibiting a powerful drive to contain the unusual. If an object appears that defies our models, the human instinct is to adjust the measurement to fit the model, rather than adjusting the model to fit the measurement. This instinct, when applied to the search for intelligence, becomes a potent filter. Imagine a data stream that shows a subtle, non-natural variation in the heat signature of a distant planet, a signature that could be interpreted as an immense, Dyson, sphere-like structure, a mythological construction built to capture a star's energy. The initial, high anomaly reading is posted. The scientific team, fearing the Oumuamua controversy or the budgetary risk of a speculative follow-up, quietly reanalyzes the data using a more conservative model of stellar flare activity. The anomaly vanishes. The great silence is preserved, not because no one is out there, but because the evidence of their presence was normalized out of existence in the archive. This mythic echo is of the Emperor's new clothes. We are so invested in the comforting, established narrative, the idea that the universe is quiet and that we are at the center of the story, that when a tiny, anomalous data point suggests otherwise, we are systemically conditioned to ignore it, or worse, quietly edit it until it fits the pre-approved narrative. The Jet Propulsion Laboratory is not a malicious entity, but a highly effective bureaucratic machine designed to deliver predictable results. Predictability, however, is the enemy of revolutionary discovery. Where are you listening from tonight? Consider the quiet irony. The sheer scale of the universe demands humility and open-mindedness. Yet the human institutions we build to study it are inevitably prone to caution and conservatism. The silent SETI filter is the collective result of thousands of small, justifiable decisions to prioritize order over anomaly. We will now gently move from the existential quiet of the great silence back to the cold, hard realities of Earth's weather. We will explore a brief, fascinating reflection on how the subtle power of non-gravitational forces, the same volatile push that was edited out of 3I Atlas, is also the primary engine of some of the most dramatic weather phenomena on our own planet. This will give us a sensory, terrestrial feeling for the subtle power of the invisible forces at work in the cosmos. Let us now sit quietly with the ultimate consequence of the silent revision, the blind spot of normalization. If, When presented with a truly unique or extreme piece of data, the system's quiet response is to adjust the archive to fit a pre-existing, less controversial model. Then we risk developing a deep, institutional short-sightedness. The subtle trimming of 3i Atlas from the highly volatile Nu 1 to the less demanding Nu 2 creates a paradigm of passivity that extends far beyond a single comet. The core function of the scientific method is to test the limits of our understanding, to look for the data that breaks the existing model. When a scientist encounters an extreme outlier, a velocity far too high, an activity level far too great, a light curve too strangely shaped, that outlier is a flashing arrow pointing toward a new physical law, a new type of object, or even an entirely new process. It is in the anomalies that the cosmos whispers its secrets. But the act of normalization, the quiet editing of the archive to bring the object into a more standard category, teaches the institution and the broader scientific community a dangerous lesson: don't trust the outlier. It suggests that if an observation seems too strange, the error is likely in the observation or the calculation, rather than in our understanding of the universe. This creates a blind spot, a psychological and procedural failure to recognize the truly unprecedented when it appears again. Imagine a future scenario, a few years from now, when the Vera Rubin Observatory comes online, an immense, wide-field camera that will revolutionize our ability to detect faint, moving objects. It will undoubtedly discover dozens, if not hundreds, of new interstellar travelers. If the established, archived precedent is that any initial high volatility reading is subsequently trimmed to fit the water ice model, then any future object that truly is rich in exotic supervolatiles, perhaps a pristine piece of a frozen, extrasolar planetesimal, will be automatically subjected to the same normalization bias. The truly revolutionary discovery will be quietly filed away as a slight measurement error. This is the great, quiet tragedy of the 3i Atlas revision. It is not the loss of a single data point, but the subtle corruption of the institutional gaze. It affects the filters we apply to the universe. We stop looking for the truly alien and start only seeing versions of ourselves reflected back in the cosmos, objects that behave according to the established rules of our own solar system. The universe is far more imaginative than any grant proposal, and by imposing our expected order on the interstellar visitors, we lose access to that magnificent, chaotic imagination. Let us return to the three anomalies that anchor our story and connect them to this new blind spot of normalization. The volatility discrepancy, the difference between the high Nu 1 and the low Nu 2, demonstrates the ability of the system to self-correct toward the expected mean, rather than embracing the unexpected extreme. The non-announcement, the lack of transparent justification for the change, teaches the next generation of scientists that data changes can happen in the archive, undermining the trust in the permanent record of observation. And the target downgrade, the reduced urgency for a dedicated mission, sends a message that exotic discovery is less important than budgetary stability. The mythic reflection here is the story of the mapmaker's fear. In ancient times, mapmakers would often write, "Here be dragons," on the edges of their known world, not because they knew dragons were there, but because they feared the unknown. The quiet revision of the 3i Atlas data is the modern-day equivalent of the astronomer or the data custodian, quietly rubbing out the "Here be exotic ices" annotation and replacing it with the comforting label, "Standard Water Comet." The fear of the unknown is quietly replaced with the illusion of certainty. This silent act of normalization is deeply rooted in the human reflection we discussed earlier. It is a desire for peace inside the scale of the cosmos. The universe is immense, indifferent, and chaotic. To maintain our sanity and our scientific focus, we try to contain its chaos in beautiful, predictive equations. The data point of nu-1 was a challenge to the equation. The quiet insertion of nu-2 restored the balance, but at the cost of genuine inquiry. As you listen, wherever you are tonight, feel the subtle tension between these two forces, the terrifying vastness of the universe and the small, human desire to categorize and control it. We are about to pivot away from the specifics of 3I Atlas and look at a grander scale, the great silence itself. We will ask if this kind of subtle, systemic normalization could be influencing not only our search for interstellar debris, but our far grander search for extraterrestrial intelligence, the quiet, profound, and deeply human question of whether we are truly alone. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo. But you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, Anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional. The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic, 4. We don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion. fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I Atlas isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I Atlas is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning. Like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field. Weak, but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, The universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation's subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time. a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order: 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously. uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, The silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern. suddenly told not to speak, and Issa, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Rolls align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3. Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. We arrive now at the conclusion of our long, quiet journey, settling our gaze upon the ultimate human reflection, the emotional cost of order over wonder. The entire story of 3I Atlas and its subtly altered data, the quiet transition from the exotic, high volatile Nu 1 to the ordinary, water ice Nu 2, is an administrative expression of a deep, human, emotional preference. The preference for order is the preference for safety, predictability, and control. A predictable comet, one that fits neatly into the water ice model, is a non-threatening comet. It allows the vast scientific apparatus to continue its work without major disruption, without a catastrophic need to find an extra $100 million for an exotic interception mission. The reward is peace of mind and institutional stability. The preference for wonder is the embrace of the anomaly, the excitement that comes from the possibility that the universe is far more bizarre and interesting than we currently imagine. The high volatility of Nu 1 was the signal of pure, unfiltered wonder, a piece of primordial material from another star system, carrying chemical signatures that challenged our understanding of cosmic formation. The reward is discovery and existential reframing. The emotional cost of choosing order over wonder is the subtle, slow erosion of the capacity for awe. When the system habitually and quietly normalizes the most extreme, exciting data points, it teaches the next generation of scientists and the public that funds them that the truly revolutionary discoveries are likely just measurement errors. The universe becomes less alien, less strange, and therefore, paradoxically, less interesting. The great silence becomes louder, not because the universe is empty, but because our filters are set too conservatively to hear its quiet, extraordinary signals. This is a subtle form of scientific fatigue, a slow, institutional burnout, where the default response to the unexpected is not investigate, but normalize. The result is a science that is incredibly precise, but profoundly cautious. A beautiful machine that is designed to find what it already knows how to look for. The sheer, vibrant chaos of the cosmos. Its true imagination is quietly replaced by the rigid elegance of a single, preferred equation. The quiet humor, one last time, is the irony of the scale. The cost of avoiding the wonder of the high volatile Nu 1 is not the loss of a physical object, which has long since sped away. The cost is the loss of a possibility, the possibility of finding an entirely new class of matter, of validating an entirely new model of star formation, of fully embracing the cosmic humility that comes from realizing we are but one part of an immense, churning machine. The mythic reflection is the ultimate human story of growth and retreat. We are forever oscillating between the desire to venture out into the unknown and the powerful, gravitational pull of the comfortable and the familiar. The story of the altered 3I Atlas data is the quiet moment of retreat, an administrative tightening of the borders around the comfortable scientific territory. Where are you listening from tonight? The deep, rhythmic breathing of the sleeping world around you is the sound of order, but the faint, distant light of the stars that stream into your eye, the light that traveled for hundreds of years to reach you, is the whisper of wonder. Hold on to that whisper and let it guide you. The mystery of the altered data will continue to unfold in the quiet spaces between the stars and in the quiet spaces between the lines of the scientific record. We may already be part of the experiment. Our journey into the quiet archives of the universe is now complete. We followed the flicker of a single, edited data point from the high, dark mountains of Hawaii to the immense, patient depths of the Oort cloud, and back again to the subtle, complex politics of human institutions. The lesson is a gentle one, rooted in the humility of our small place in the cosmos. History bends, but it never truly breaks, and the universe in its indifferent, sublime majesty is always richer and stranger than the footnotes we assign to it. Our ancestors survived a soup of microbes and cosmic dust that might kill you, and our journey is no less perilous or profound. We are grateful for their endurance, and for yours. Now, as the world settles into its deepest rhythm, allow the weight of the vast, quiet universe to settle over you, not as a challenge, but as a vast, dark blanket. Let the subtle, rhythmic passage of those distant, wandering stars be the quiet rhythm that guides you toward a deep, gentle, and well-earned rest. Thank you for listening, and sleep well.